I want to just extend what we've been doing very slightly. It's not much at all, really. Why don't you close that up, Marcus? Thank you. So quick review, like when we did a problem like this yesterday, right? Or maybe the day before, I can't remember. When we want to graph an inequality, what are the steps we go through here? What's the first thing we're going to do? Good, we want to put it in slope-intercept form. So we isolate y. It makes it easier to graph the boundary line, and it makes it easier to determine where we're going to shade, right? So we solve for y, get y by itself. Then when we're graphing our boundary line, so here's, we solve for y, right? We put it in slope-intercept form. How do we know if it's going to be a dashed or solid boundary line? What do you think? Okay. Okay, good. The inequality sign, it's gonna, when is it solid? If it includes, if it includes an equal sign. Good. So if it includes equals, then it's solid. If it does not, if it's just a plain old inequality symbol, then it would be a dashed boundary line, right? And then lastly, how do we know, Autumn, how do we know whether we're shading above or below?
If y is less than or greater than.
Perfect. If it's less than or greater, if it's less than, we're shading below, greater than, we're shading above. Perfect. We got it. Okay? So let's look at, let's before we jump into anything new, let's take an application of this and just kind of see how this is a little bit different than the applications of linear equations. Very slightly. It's almost the same thing. But I know this is probably the hardest thing we do in math, right? Is our applications in math. So the more practice we get, the better we're going to be. What about this one? Stephanie spends 10 cents per text message sent and 25 cents per picture sent on her cell phone. Her monthly budget for messaging is $30. So we're supposed to write a linear inequality to represent the situation, right? So if you think about this now, I mean, what's the gist of this question? We want to know how is she gonna, if she's got a budget, we want to know how is she gonna stay in her budget, right? Staying in her budget just means she can't spend more than $30 on her cell phone plan. So the cost of her cell phone plan is going to depend on what? What are the things what are the unknowns that we're not given here that we need to include? What's one of them?
Amount of text messages sent.
Okay, good. So the amount, the number of text messages, and then probably the other one is the number of pictures. Okay, so let's define those as our variables, right? So we'll say, let's just call it x and y. So x equals number of texts, and y equals number of pictures, right? And if we do that, let's come up with an inequality that represents this situation. And so what's going to be the expression that's going to determine how much she's spending? And I'm not worried about the $30 yet, but just how do we come up with an expression involving x's and y's that's going to determine how much she's spending? What do you think? Dominic, you got an idea? Okay, good. And what might it be? What times x? What do you think? Good. That's telling us how much she's spending on her plan, right? Depends on the number of texts and the number of pics. So what does the 30 have to do with it? It's the limit. Okay, so then if her budget is $30, what are some amounts that she could safely spend?
Anything less than $30.
Anything less than 30, could she spend 30? Okay, so anything $30 or less. Does that make sense? So how would we say that is an inequality?
Less than or equal to.
Less than or equal to 30. Good. There we go. Right. And if we wanted to graph this thing, we're going to follow our steps from before. We got to solve for y, right? So if I want to solve for y, what am I going to do to get the y by itself? Nancy, what's the first thing I'm going to do to get that y by itself?
Subtract the 10x.
Okay, good. So we're going to move the x term to the other side. Subtract it to the other side. Very good. So this is going to have to get pushed over there. And that's going to give us, we're left with a 0.25x on the left side. On the right side, we subtracted that over there, so we're going to get a negative. Good. Oops.
Y.
Oh, I got it backwards, didn't I? Whoops. Start over. You're trying to fix this, but I wasn't listening. So 0.25y is less than or equal to, we moved the x term over here so it becomes negative, right? And then we've got a 30 over there also. So last step? Good, divide by 0.25. Okay, if we do all that stuff then, we're gonna get y by itself. Now what about this? I'm gonna have the fraction negative 0.10 divided by 0.25. And I could do that on a calculator, but let's not. Let's see if we can just power through that. Negative 0.10 divided by 0.25. What could I do? What do you think, John? What could I do?
Take a 5 out of it?
I could. Before we do that, what maybe with the decimals? What could we do with the decimals? What do you think? Now think what this means. What is that number? 0.10 is what? 10 what?
Tens.
Not tens.
Hundreds.
Hundredths, right? Because the decimal's 2 places over. So I've got 10 hundredths divided by 25 hundredths. I can move the decimal, couldn't I? That's the same thing. If I multiply the top and the bottom by 100, the same thing as moving the decimal 2 places, right? So I could rewrite that as negative 10 over 25. And that reduces to what? What could I divide into both of those? 2/5. I divide 5 into both of those. Good. So that's going to look like then negative 2/5 x. And then I've got 30. The other fraction I have to deal with is 30 divided by 0.25. And we could do the same thing. We could move the decimal and get 3,000 over 25. But think about it this way. What is 0.25 as a fraction? It's 1/4, isn't it? So we got an easy way we could do this. I've got 30 divided by 1/4. What's our rule when we divide by a fraction? What do we do? Yeah, flip and multiply, right? So this is the same thing as saying 30 times the reciprocal of 1/4, which is 4. So what's that going to give us? 120, yeah. So there's our inequality, right? Okay. So we got to graph that. Now, when we graph that, let's see. I'm gonna have to probably change the scale, aren't I? Because I don't 120. If I go by ones, that's gonna be through the roof. So we're gonna go by 10. So that's 10, 20, etc. 30, 40, 50, 60, 70, 80, 90, 100, 10, 20. So right there is where we want to be. There's our y-intercept, right? Okay. Now, what about this slope? It's another thing we got to kind of think about here. What am I going to do with the slope? I would recommend when you're changing the scale on a graph like this, it's pretty convenient to change both the x and the y scales to be the same. And you'll see why in just a second. So we're going to do the same thing here. We're going to make this go by tens. Right? Okay, so now the slope is negative 2/5. Does that mean that I have to go down 2 and over 5? Can you give me another combination of things I could do and also end up on the line? I could go down 2 and over 5, or go down 20 and over 50. Anything that reduces to negative 2/5 is going to work. I could go down 4 and over 10, right? I could go down 2,000 and over 5,000 if I really want to go a long ways, right? But in this case, it makes sense to go down 20 and over 50, because that's still the ratio of negative 2/5, right? And so that's what that looks like. There I went down 20, now I'm going over 50. There's my next point, and I'm going to graph my line. Okay, another question. My lines go forever, right? Should this line go forever? Where would it stop? I mean, like if I'm drawing it this way, tell me when I should stop drawing. Right there. How come? What does x represent? Number of ticks. So if I go past the y-axis, I've got negative x values, right? Does that make sense in context of this problem? You can't have a negative number of text messages, right? So we could just go ahead and stop there. And then I'll keep going in that direction until I hit the x-axis. But I don't want to go below the x-axis because I can't have negative y values either, can I? Right? Okay, and then are we shading above or below?
Below.
Below, okay. And once again, we don't want to shade anything outside of quadrant 1 because it doesn't make sense for us to shade any region where we have negative x or y values, does it? Right? So we would just shade it like this. Right, you get the idea. Okay. I want to show you how this works on Desmos. It's really slick. we can do this stuff. Like on the applications problems, on the test, I'd probably be willing to let you use Desmos to solve the system. Okay, so. Okay, so in Desmos, look what we can do. We can go, where's our two? Oh, it's kind of inconvenient. They're right in the middle. Or it's right in the middle. Okay, so there it is, right? Negative 2/5 x plus 12. Oh, 120, yeah. Okay, so y is, if I just say less than negative 2/5 x plus 120, look what it does. It's pretty smart, right? It graphs the region with a dashed line. Okay, but it's not supposed to be less than, it's supposed to be less than or equal to. Any suggestions how I might change that to a less than or equal? Yeah, I just put the equals right after the less than, and look, it changes it to a solid line. Pretty cool. Okay, so now what about this one? How could I maybe, well, we'll come back to this in a second. We'll come back to this one. Yes, sir. Yes, you may. So then they want to know, give 2 possible combinations of text and picture messages she can send and stay within her budget. Well, where would I find examples of numbers of text and numbers of pictures that would work? Like up there? No. In there? There you go. The shaded region is the solution, right? So any ordered pair in here, any of those 3, 4, whatever, those are all going to work. Right, those ordered pairs correspond to numbers of text, that's the x coordinate, numbers of pictures. Those would all work because they're part of the solution. Okay? All right, so next issue then is, what if we have more than one inequality at the same time? Then it becomes a system, right? Because a system just means more than one of something. So what do you think is going to happen here? And I'm going to skip this. I'm only going to do one example with you guys. That's all it's going to take. So I want to do one where we have to actually isolate y. Okay? So what about this one? I'm going to graph each of these inequalities, so walk me through that. What about the first one? This will be blue. What I got to do there? Subtract 7x. First thing I got to do is push the x term. I'm going to isolate y, right? So first step would be we're going to get 3y is less than or equal to negative 7x plus 18. Everybody agree? Okay, what's next? Divide by 3. Okay? If I divide everything by 3, I'm going to get y by itself is less than or equal to, what's the fraction going to be? The m? Good. Negative 7/3 plus what's being 6. Okay, so let's graph that one. Where do I start? 6. What's my slope triangle tell me to do?
Put down 7.
So down 7 over 3, good. Solid or dashed? Solid. Shading above or below? Below. Good. So there's that inequality. Okay. Now we're moving on. Part 2. This will be our red inequality. What am I going to do there? Subtract 2x. First thing I'm going to do is subtract 2x. So I'm going to get negative 3y is less than or equal to negative 2x plus 9. Now what? Okay, divide by negative 3. Now, Molly, what am I going to have to remember to do if I'm dividing by a negative? Okay, true. Well, what about the inequality? Got to flip it, don't I? Good. Okay, so because we're dividing by a negative, I'm going to have to be careful. I'm going to have to flip that around, right? So what do we end up with then? On the left side, we've got our y. The inequality is getting flipped. Negative 2 divided by negative 3 is 2/3. 9 divided by negative 3 is negative 3. Okay, so let's graph that one. Where do I start? -3. So right there, slope triangle is gonna have me do what? Go up 2 and over 3, right? So I'm right there. Okay? Now what? Solid or dashed? Solid. Shading above or below? Above.
Shows like the skin color.
Okay, so what's my solution this time? What are you pointing at there, John? Ah, okay, the region of overlapping shading, right? I think what it means to be a solution of a system, you have to satisfy all the parts of the system. So in this case, the solutions of this would be the solutions of both of those linear inequalities at the same time. So that's the double shaded region, isn't it? Right, so if I wanted to section off that part, the borderlines would be included, wouldn't they? Right, because this is a solid boundary that's inside the blue region, agreed? So that would be included. That borderline would be included also because it's the blue boundary that's in the red region. So that, and then everything inside that, right? So all this stuff. Make sense? Okay, that's it. So then if we go back to this last one, here's what I want to do. I want to go back to this last one. And in Desmos, how could I, this is tricky. See if you can come up with this. This was our solution to the word problem, right? Okay, but we said we didn't really want to include negative x or y values. So how could I include maybe some other inequalities there that would make that only happen in quadrant 1, where x is not negative and y is not negative? What do I need to say about x? What do you think?
I just scratch.
Oh, okay. That's allowed. It's pretty quick on that draw, wasn't it? So, what do you think? How could I say only x values that are not negative? What would that include? 0 and positive, right? How could I say that with an inequality? X has to be what?
Greater than or equal to 0.
Ah, okay, let's try that. X is greater than or equal to 0. Hey, what do you know? That worked. Okay, that gave us only this double shaded region now works, but we want to not allow y to be negative either. So what do I need to say there?
Same thing.
Y is greater than or equal to 0. And let's get a different color here. How about, let's go orange, and we'll go green. So now that's a little better. So now we can see this is the only triple shaded region, isn't it? That's the part we were looking for, right? Does that make sense? Yes,
How
Anthony?
do we type in the greater than or equal?
You just do the greater than and then an equal right after it, and it puts them together.
Okay.
Yep. Okay, so last one then. Last one, and you guys can work. Okay, what about this now? So all we're gonna do, and we won't spend time graphing it, we can let Desmos graph it for us. But it says to raise money to attend Boy Scout camp, Alex selling popcorn. Small bags of popcorn sell for $4 each, large bags sell for $6 each, right? He needs to earn at least $300 to attend camp. He will also earn a badge if he sells at least 60 bags of any combination, okay? So he wants to get a badge and attend the camp. So let's see, what are we gonna do? We gotta set up some inequalities maybe to model that. So what about the first part? Well, what are the unknowns here?
Amount of bags sold,
Yeah.
large and small.
Number of bags sold, right? 'Cause we're trying to figure out, he's gotta figure out how much he's making. He's gotta make at least 300. But we know the cost of each bag, but we gotta know how many he's selling to determine how much he makes, right? So just like before, we've got x equals, we'll call it number of small bags. Y equals number of large bags. And what's our first inequality gonna be then? The one that deals with the $300, how about?
4x plus 6y equals $300.
Everybody agree with that? But equals?
Greater than or equal to.
Great, okay, good, because look, it's gotta be, he's gotta earn at least 300, so he could earn 300 or more. He'd be fine, earn 400 would be great. But he has to earn at least 300, so greater than or equal to 300. Okay, what about the other one? How about this one where he needs to sell at least 60 bags total?
X plus y is greater than or equal to 60.
Does that make sense? Because the total number of bags is just gonna be the number of small plus the number of large, so X plus Y is greater than or equal to 60. So let's do this on Desmos.
I see how this is gonna work already.
Let's see how this is gonna
I
work.
get it. I mean, the no hesitation. Okay, so here.
Okay, so then we've got, I'll turn these off for a second. So we got the blue one now is gonna be 4x. We don't even have to put this in. If we're using Desmos, we don't need to solve for y, right? It'll take it in any form. Standard form's fine. So 4x plus 6y is greater than or equal to 300. Yes, sir. Yes, sir. So there's the blue inequality, the first one, correct? Okay, then the next one is going to be, we had x plus y is greater than or equal to 60. Okay, now let's turn that one on. So there's another one. Now we got the dark green region. But once again, can I sell a negative number of bags of either kind? So what are the other two I need to include? X is greater than 0 and y is greater than or equal to 0. Right, and let's get that one's going to be purple. All right, there we go. So then that's our solution set. Everything kind of the, what is it, a plum color? I don't know. Up there. Is that plum colored, Mackenzie? What do you think? Good enough? Good enough? All right. All right. Okay, make sense? Okay. Go.
Wait, so what would the answer be?
That's the answer. Right? That's, here, let me take a picture of that and I'll put it on our notes.
No, but like when we go orange says, or like black.
Okay, so, right, so what you're gonna do for this assignment, I've got one little word problem left. All I have to do is set it up. The answer is gonna be, you gotta pick the right system, the graph of the correct system.
Oh, okay.
See what I'm saying?
So it's just a
graph
picture.
it'll be like that, but you just have to click on which
You gotta pick which one is the right one. Yeah, does that make sense?
Yeah.
Okay.
So we had a